Hi there, this is Dr. Moyer, and we are going to cover the two different types of variables tonight for statistics. The first kind of variable is called a continuous variable. These are numbers, numeric variables, and they come to you naturally in numeric form. We'll talk about why the result is meaningful in a moment, but I have to warn you, I have a little bit of a cold and need to keep pausing to take a drink. So I don't cough. Anyways, some examples are age, height, weight, temperature, blood pressure, GPA, number of children, number of months in a relationship, number of hours of sleep per night. And it's important to recognize that social science researchers also use Likert type scales as continuous variables. So I have three examples here. All are continuous variables. Number one, what is your age? Number two, how many times have you been married? And then number three, how much do you enjoy surfing the internet? Notice that the last one is a Likert scale on ranges from 1 to 5, not at all to very much. And the other two, you fill in the number. It may be tempting to use categories for age, and a lot of people do. I'm not really sure why. I think they just think that's what they're supposed to do. But if you have categories, it limits the kind of statistics that you can do. We'll talk more about that at the end, but you'll see what I mean. And the same for anything that can be answered in a number. You want to think about that. If it can be answered in a number, it's better to leave it that way than to break it down into categories, unless you absolutely have to for some reason. And then, of course, the Likert scale. Someone circled number 5. And we'll talk about these answers. So, 29. If I divided 29, I'd get 14.5, right? Well, that number would still mean something, because people can be 14.5 years old. It's realistic. It's literally half of 29, because 29 is a number that has meaning. The same with the number 2. Been married 2 times. That number 2 is a real number. It means something. If I added 2 more years to that, I'd get 4. So I'd have been married 4 years. And it would still have meaning. It would be double what 2 is. If I had 5, that number means something because it's saying very much. It represents very much on this scale. How much do you enjoy surfing the internet? If I circled a 2 or a 1, that would be not at all. If I divided 5, it would fall somewhere here, 2.5. That would still mean something because it would still be on the scale. It would just be between 2 and 3, and that I don't enjoy surfing the internet as much as 3, 4, or 5 would indicate. So, that's continuous variables. And you have to remember, again, that they come to us in numeric form. So we don't want to change that. Categorical variables, on the other hand, are variables that have categories for answers, but the numbers that they're assigned, the numbers that get assigned to them by the researcher don't have any meaning. I'm sorry, this cold is killing me. Hold on a second. So they're numbers that we pick arbitrarily, just out of the air, because we have to enter a number into Excel. If we want to compute statistics, or quantitative statistics, then we have to do that. So, here's 2 examples. What is your marital status, and what is your favorite type of TV show? So there's 2 options for the first one. And then there are 6 options for the second one. But I can't put these into Excel. I can't put married, 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 married. Or even A. There has to be a number. So I'm going to assign a number 1 to married, only because it's the first choice, and that makes sense. And a number 2 to not married. And then I'll start with 1 for comedy and go down to number 6 for the cooking show. So after I've done that, I've assigned values. These numbers, although they are numbers now, they don't really have any true meaning. I could switch these. So not married could be 1, and married could be 2. It would make no difference. It wouldn't change the number, or it wouldn't change the meaning. What matters is what I've assigned to it. And the same with this. I could move these all around, and it wouldn't matter. Game show doesn't have to be coded as 5. I could move it to number 1, I could move it to number 2, whatever. So that's what we mean by meaning. If you add or subtract them, you really can't do that, actually. So if somebody coded drama 4 and you divided that number, the number 4, in half, you'd get 2. But what does that number mean? I mean, here you want to say, well, that means reality shows. Yes, but only because we've assigned a 2 to that. The number 4 means nothing. It just means that's the code for drama that we enter into Excel. And so one of the more common statistics used is the mean, or the average. If I wanted to calculate the average, I would add the numbers up. Say there were 6 entries, add up what 6 people had put in, get a sum, then I divide it by 6. Well, let's say that ended up being 1.73. What is that? You may be tempted to say, well, it's somewhere between comedy and reality. Yeah, but that numerically doesn't exist. So what does that mean? And again, you might be tempted to say, well, it's closer to reality, so we'd call it reality. So the average is reality. Well, you can't actually compute an average on categorical variables. So you wouldn't compute the mean. You would instead find out what percentage of the sample said comedy, what percent said reality, what percent said sports, etc. That would be more meaningful to report. So why does this matter? Honestly, this is probably one of the most important lectures that I can give you, because if you can break down any variable from a survey into either continuous or categorical, then you can figure out what statistics you are able to run. You can't run certain statistics with certain types of variables. And if you refer to the statistics cheat sheet under D2L, I put a copy here, you'll see that I have spelled it out for you. So the mean, or the average, can only be computed on continuous variables. So you'll know that. If you have continuous variables, you can calculate a mean. Frequencies and percentages, actual number of times the value appears in a data set, what percent of data is represented by a value, it's typically only computed on categorical variables. Doesn't mean it can't be done with continuous, but it wouldn't make much sense to do that. You would compute a mean, the average. And then we get into the types of tests where you can look for statistical significance, chi-square, an independent samples t-test, correlations, and an ANOVA. And those are also limited by the kinds of variables that you have. You can only compute a correlation, for example, with 2 continuous variables. You can't use categorical. So when it comes time to determine the statistical analysis for your projects or for anything else you're doing where you need to do that, you can figure out what you can and can't do simply by breaking down the variables into one of those 2 types. I hope that makes sense. That really, it's an important lecture, and you're going to hear me refer to those 2 types of variables from here on out. I encourage you to review this PowerPoint as often as necessary so that you get this in your head and you understand the difference between the 2. Very important. Sorry for my cold. Really can't breathe. Apologize for coughing. I hope this is better before my next PowerPoint experience.